and sort of talking through some of the provocations we got from Carl and Matthias, because we're always so sort of I guess with something like this, there's always that notion of where do you start being creative and where do we have or experience limitations. So actually, when you guys did start with the geometries and slowly started to sort of put it in Bianco's workspace, what do you guys think were your biggest challenges or the most frustrating part? Any thoughts on that?
May I go? For the frustrating part, I don't know, like the frustrating part, but like as far as the concerned, I'm very happy, and I like, having been enrolled in this workshop, I learned a lot. And trust me, I haven't used like robot even in grasshopper simulations, and now I can like at least I can operate 3-4 tools like the movement, the drilling, miling. What else was there? Hardware cutting, and today I explored pick and place.
Yeah.
So this is like a very nice thing that a robot is moving like just point to point, just tools are changing and the way you're creating the path. And I really like your teaching methods and presentations and stuff. And you can see that everyone picked up. So
That's
well,
really
yeah.
insightful.
Yeah.
Thanks so
So
much.
thank
Do
you
you
so
think,
much, guys, for
yeah,
introducing this amazing workshop.
absolutely. Do you think you would be, I don't know, like would this work be influencing your academic or professional work in a few ways?
Of course.
Or,
Absolutely. Yesterday, even I and Sarah, Jeff, and Emily were talking about that only, like the place where I'm working in Swinburne University. We're having heaps amount of robots, but I don't know how to operate any of those. I can if I have knowledge, but I don't. So yeah, it will definitely be very helpful.
yeah, we
And
really
we
hope
have,
this opens up doors for you.
yeah, we have ABB special pattern. We have Rohaku concrete 3D printing. We have one more 3D printing that does like concrete printing. And there's one else like that is KUKA, but I don't know the model number.
Yeah.
That's the
It's
huge
interesting that
one.
you mentioned what companies they're from, because I mean that's almost like discussing cars, right? Because
Yeah,
I mean the function of the car still kind of remains the same. So I guess in a lot of ways, if you understand the concepts of a KUKA, like jumping to an ABB would be a slightly different interface, but I mean the function of that and the logics of that still pretty much remains the same. So I guess,
remains the same.
yeah.
That's true. The path and the movement. I was going to ask you the same question like the other day, but like I don't know it passed or what happened. The if we are controlling just the movement of the robot, then why it is different from like KUKA to ABB? Why can't it be the same if like they are having the same size?
Uh, oh wait, do you mean in terms of how you generate toolpaths or just how you
Yes,
communicate with them?
just toolpath.
I mean, it does have a very similar analogy because recently I was jumping between ABB and KUKA, and I guess as soon as you understand the logics and the movements and limitations and capacities, of course, of one robot, that pretty much lets you sort of jump into another one with great ease. Yeah,
Yeah.
yeah. It's
And
it's all
also,
about, yeah. Sorry, go ahead.
yeah, I also imagine that there's a software part. So basically, there's a computer in which you are like plugging the scripts, and that the robot will use to process information. So it's like talking about like having a new computer, because now we have new versions of robot that have fancy touchscreen touch pendants. They're like smaller, nicer, and like more like easier to handle. So there are all like these things as well in terms of like the user friendly experience
Mhm. Yeah, it's
for
almost
certain
like
things.
having that uh, Apple Android conversation, but the function of it still remains the same. You just have to get your call
Yeah.
through. So I guess, yeah, that's the easiest example I could come with. But I hope you get the chance to check out the robots on your end for sure.
Yeah, sure, sure. I was thinking like it's gonna be too complicated. Actually, at the first, first go, like when you're new to robotics, you don't know the G code and stuff, like a huge amount of text number, how robot interprets that, and it was like a big frustration in the beginning, but like right now, it's like it seems very simple. I don't know, I haven't tested it yet with the robot, but hopefully I will, and
Yeah.
I'll share you guys like the results if I come up with something.
Also, you have to.
Sure.
You must. So I'd be curious to know. So you guys, some of you told us already that you don't have access to robots in your institution. I'd be curious to know, like, is this the case for like any of you guys? Like, who doesn't? Because there are like sometimes maybe in my institution there's a robot, nobody really knows what to do with that, so we're not using it. Or there's the flip side, like we don't have that technology. So I'd be curious to know, even like if you do not have a robot in the build lab in your school, what led you to, like to this interest, and what did you find? Like, how did you came across robotics? And I don't know, tell us.
Well, hi. I think here my university they don't have robots, but this kind of new way to generate toolpaths with Grasshopper help us on me and some friends help us to push the boundaries of like 3D printers. We have a clay 3D printer too, but it's not a robot, it's a three-axis uh, 3D printer. So I sort of knew how to generate toolpaths with Grasshopper, but this new approach to change the axis of the I don't know of the toolpaths, it blew my mind because now I can see how push further the toolpath and the things that you can do with a robot. So here in my city, there are some companies that have robots, and the thing that mentioned yesterday, Carl, I think, is to search that with our knowledge we can knock some doors and tell them that we know how to do things and how to design and how to use the robots. So I think I'm gonna be asking some people to play with their toys a little bit. So this workshop gives me that opportunity to do that. So I'm very thankful for you.
And you're advancing this knowledge soon, right? Like
Yeah.
next
Did you say
next
you're
term.
headed to Barcelona? Was that you?
Yes, yes. In a couple of months, I will go there to maybe a study, but in the meantime, I will work definitely there a couple of months. But uh, but yeah, I can see Carl there. But seeing the presentation from yesterday from Carl, it was like an entrepreneur when it sees the film like the Wolf of Wall Street. That I don't know if you haven't seen that film, guys, but
Yeah, like
in
5 times.
yes, in a good way. Uh, taking out all the drug and the sex stuff, but uh, in you after you have seen that movie, you are like, oh, I'm gonna hit the work right now. I'm I had to be the best at my thing, But seeing like his career and the things that he showed yesterday, made me think like that. So it's very inspiring.
I think that this was a comment for you, Carl. Do you need other more 5 minutes to wake up entirely?
I'm okay. I'm okay.
So, how do we want to manage this?
All right. I'm seeing the presentation, so I guess we could get started with that. So we could also spend
The
some
last
time
one?
discussing those. Yeah. Day 5, right here.
Okay. So, yeah, we have. So, Carl, good morning again. We have some good stuff to show you here. Two different approaches. Either we start with the last with the last submissions and we go backward, or we can show you, like a sneak peek of what happened in these days, starting from the amazing assignment through light bright subtraction, hotwire cutting, and then we get to the last one. What do you think is the most effective way?
You're gonna need to decide. Don't make whatever you want.
First to last. First to last
To
will work
last.
fine, I think.
Yeah, I guess we
First to
could give him
last.
a quick crash course about
Yeah.
what we sort of touched base on and then elaborate on day 5.
Yeah, let's do this then. So Carl, I don't know if we ever described to you basically the content of this of the workshop, but basically we structured it in daily assignments in a way that through the week the students had a sense of really how to well, first of all, to program the robot. To understand a bit of terminology, what it means to create a toolpath, what it means, to install an end effector, to customize production on any way the text of the robot. And so day one, we introduced KUKA PRC, we introduced some ideas in terms of robotics and design and architecture. And our request for the submission was really for them to represent the robot and the kinematic and this process, starting from a exercise that you know very well. Was the first assignment that we issued at LTU a few years ago. And so, yes, we talked about this notion of digital twin, of like creating this relationship between time and space, and to use simulations as a way, to understand what potentially can happen in the physical space, to detect issues in the scripting, or in case we need to touch the material, we check if there are like collisions that we want to get rid of, and so on and so forth. So we started from, and we're seeing here some very interesting examples of representation, and knowing that this is skill building, right? So we're not touching the material yet. We're not crafting forms yet. It's really like a way to get in touch with robot programming, hopefully not scaring the students, but I try to show them that they just need to think in a certain way, to think about like designing the process, designing the motions, and to structure their geometries that they want to achieve, if they want to produce something into points. So once they have this notion of target points and connection of target points to create a toolpath, then basically it's all they need to know to use this approach for other processes. Yeah, so representation. So, and one of the things that we mentioned was like, imagine to have this in your portfolio. This is a good way to start and learn how to represent these things. And then we can talk more specifically about design. design processes. Did I cover everything here?
Yep, on point. So in a lot of ways, what we were trying to do with the first 2-3 days was sort of introduce one assignment every day. So almost like building blocks or ways to sort of understand what it can and cannot do, different types of motions and different end effectors, and how that sort of translates into certain geometries or the other way around. And I think this was by far, like, I think everyone agrees that this was their favorite assignment, just because they got to actually sort of see the translation of points to lines and into 3D with Jeff and Emily walking us through what's happening in the build lab. So I guess this was also a big jump in a lot of ways to sort of really jump from digital to physical and see it happen in real time.
Yeah, and also we saw a bit more of authorship starting from this point, because they really showed us their skills, their creativity to create geometries, absurd geometries in space. And of course, at the end, there's a reason why we thought. I mean, we considered this assignment for them to test the robot. So there was the first moment in which we connected the digital simulation in reality, in the real space, connecting, just sending the scripts to the build lab, so that at the end we produced the long exposure pictures of these geometries to understand the motion, to understand the kinematic, to really find this point of contact with the real space, physical space. And yeah, I guess we didn't add the final photos in the presentation. We can share that as well. But I think that the results are fascinating. Too bad this is not loading. Let's see. I can come back. It's taking a second, but really you can see how, and also you can have a sense of their skills with Grasshopper. So it's good that, like, you don't have to put too much stuff on the plate, because if you know already how Grasshopper works and how to think in terms of generative design, then you just need to focus on the second part of the workflow, in which we are turning that geometry into something that is suitable for the robot scripting. More examples. It's really, you can see, like, I think we talked about this specific summation the other day, just in terms of really like just navigating, around the robot and showing with the camera and showing what the robot is doing. And another examples to try also to imagine these lines, these toolpaths as potential geometry. So once you really want to visualize sort of an object and to abstract that object, and again, and visualizing something that is not visible through light. And more examples, and we might be able to show you the pictures as well at the end. Yes, we go. And then we explore different approaches. Here, Misri showed us a lot of her work at Ballard. We talked about that as well. And of course, we didn't have the possibility, to try this process with Bianco and the build lab. We still do not have this end effector at the moment. We'll see what we can do in the future. We start seeing here like an interpretation also of the forms that they have produced in terms of, is this a scale model? Is this a unit, a building unit to think about an assembly or something larger scale? trying. I think we sort of increased and loosened and relaxed the level of stress through the assignments as well, because we asked them to be more careful for the light bright and the hot wire cutting assignment, because they were dealing with the robot as well, not only with the simulation, in which if there's a collision, matters, but not that much. And it's interesting to see how, like, for this assignment, they had a few of them had this idea of imagining, this process to create a topography, to create an articulated, complex geometry, having in mind, like, what's the best way to accomplish a task, what's the best end effector to produce something. Is through a subtractive method the best way to obtain this geometry, or is it worth it to 3D print it or not? How about the outwire? And so we looked into these things in this week.
I mean,
More.
I'm trying to think through some of this a little bit on this assignment. I haven't seen anything that's more than a 3-axis. Right. And so, but I guess I'm trying to think of a different, and maybe for the students, we've done another, did you show them the pinhead assignment at all? No.
Mentioned.
Like,
we mentioned
that. Yeah.
Only because I'm thinking about it in the context of, like, we talked yesterday about, well, the way that the students in the workshop are working is not unlike the way that you might work with a fabricator. And then I'm kind of like, well, do we actually need to mill material in order to understand it? Like, the students can, like, what's nice about what we're seeing is the students can, well, I don't know, maybe I'm undermining the assignment a little bit. Like, for a long time, I was never really interested in 3D printing because it was just a simple output of what we had digitally. Like, it didn't feel like 3D printing gave us much more than what we already knew digitally. And so I'm kind of like thinking through with this assignment, like, well, the students have their digital model. Basically, the output is the digital model. Like, does it change anything? Does it do anything? Do we actually have to mill material to understand what we're going to get? We already know what we have. And I started thinking about pinhead only because, like, let's say the scenario is the one that we have, right? The students work with a remote fabricator. I have this digital form. I want it milled. Okay, here's your form, and it's done. What we do with another assignment that we created was that we mill a form, and then we use the robot to place pins in that surface. And so, in the way that Misri and Sarah have kind of talked about taking you guys from, like, not touching a material to looking at form to doing other things. And maybe you have a couple of images, Sarah, that you can show, but the physical artifact becomes important because we then have to map that back digitally. And then we use the robot to place things that are very specific in their placement in relationship to the 3-dimensional form. So do you have any images that you can show for that, Sarah? Just to give the students a sense of, like, what might happen, like, if this were a kind of workflow and we had more than a couple of hours a day for 5 days, what might happen with that?
You mean related to the pinhead exercise, like,
Yeah.
to show?
Yeah, I think we have it.
When was it?
Slides.
Day 5, maybe. Too much fabrication. I think we talked about. I think it might be the first one, actually.
So there's an image of one.
Yeah, there's an image, but we also have. Yeah, we have image
also just
and
the fact that the more we started to jump into, like, the latter processes, it became more about, like, using the process as a way to design instead of starting with this digital form that needs to be sort of come to life in its physical being, but instead sort of looking at a process which, with certain kind of rules and procedural logic, sort of comes up with a form of its own. So I think even with the wire cutter, and also with Milling, what we were trying to achieve was to generate the tool paths instead of generating the 3D geometry to see what sort of 3D geometry comes out of 2D tool pathing.
And I
And
also
like,
think, no,
I
go
was just
ahead,
going to
Kurt.
say, like, there's an image on the screen where you can see the relationship of a digital form that's been made physical through milling and subtraction, but then we also have to go and understand that digitally so that then Bianco can place pins on the surface that are normal to the surface. And that actually requires the multiple axes of the robot to actually position them normal to the surface. Whereas what I'm seeing with a lot of the milling is that the milling head is essentially vertical, which is a kind of 2.5D process instead of say like a 6 or 7 axis process. And so I think that's just a kind of extension of, you know, where what everyone did with this assignment, where we can imagine those kind of going to the next level. But I mean, we sometimes the complexity, and this is maybe just a bigger discussion of things, the complexity of programming with a robot is exponentially more than that of a CNC router. And so if you can mill something with a CNC router, you typically will.
Can I jump in and say something? I think that a lot of ground was covered in a week. And on a practical level, it's all about the target planes, right? You know, it's not just the points, but it's the orientation of the planes, you know, and working with the files, you know, I could see kind of some development, you know, over the course of days. And I do kind of wish that maybe some things had gotten moved a little bit. But that was personal as well, in terms of preference. Yeah, you could see in later assignments how the orientation of planes really comes into play. That knowledge, though, would need to kind of get back, kind of wrapped around to this assignment, which came earlier. So the orientation of planes was much more important for the students to use in the hot wire part. And so it was maybe less apparent in the milling.
And I think the milling is a good, and maybe like we saw, what the students kind of understand now is the kind of progression in the way that we're leading you through the things. So like the maze, the robot never touches anything, right? And it's like, okay, you understand the concepts, then we start to go somewhere else. I think the kind of 3D milling gives you a kind of glimpse into what can be made, but I think you can also get a sense for that the freedom that we have with a robot is that you can actually make some forms that you can't make with a 3-axis CNC router. And I think there's some opportunities there. And so starting for all the students in the class to be able to kind of project beyond that. And then I think, yeah, the progression then to the hot wire cutter is all of a sudden you're working with this thing from, you know, the cube almost from all 6 sides, right? That you can start to produce something. But the milling, like so much of it in industry is actually how you hold the piece down and the kind of the fixturing, and so that you can get access to it and how you move it around and all of those types of things. And so it can get very complicated very quickly. But I think the key concepts, at least that I'm seeing here, are kind of present in that work, which is nice.
I think that we had that conversation. To me, it's always interesting, you know, to think about the different workflows and to understand what's our level of engagement with the materials when we use digital tools. So as you mentioned, the 3D printing, you know, like you plug the file and you go for a walk, you come back, you have the model, and not necessarily that increases your understanding of the materiality. But yeah, so as we were saying, like the more we advance here with the assignments and with the complexity and with the rotations, the more I think there's more room for that kind of understanding and that like we can generate more discussion between, like the digital file and the physical implementation, also because then we have the temperature of the wire, we have the speed of the robot, like if you stay in one point for longer time, you have a different result. So there's, I think, just like the more we increase the scripting, the complexity, we're trying to increase the complexity also of that part, like the understanding of the materials and how we can craft that, and what kind of results we can achieve through like adding, like making the toolpath and the planes, and like tweaking all these input data in a more sophisticated way, I think.
And in general, with the hot wire cutter, I think the students were sort of, it was a good geometric challenge as well, just because everything had to be a rule surface. And we also sort of, you think of Gaudi's forms and you think they're too organic, but they're all ruled surfaces. All right, yeah.
And then,
yes.
go ahead.
No, go ahead. I was just gonna echo what you just said.
Yeah, that sounds great. And also, Carl, if you notice, we always tried to imagine this as a inspiration for architecture. And so you can see really, like, imagine that this was one day assignment. Usually there are weekly assignments, right? So like the fact that we start to see, like the deployment of positive and negative space, and try to imagine them in a larger system, and try to have an idea of the scale, and combination of inside and outside, indoor, outdoor, or mixed spaces, I think was a successful, I think, stream of ideas. And yeah, so all these exercises and thoughts and ideas at the end converge into the last submission. And
were we able to cut those?
Yes, yes. We don't have the images yet. I can, because we are in the process of, I might show you some videos though. Not customized. I'm picking one randomly. We are starting to see here some videos, and also we'll get the photographic documentation soon. I haven't checked them yet, so I don't know what's going on. But yes, we documented this process as well for them, and we did a couple of demos as well. You were here yesterday. In the last 10 minutes, we showed as well.
So these got cut yesterday. Is that right?
Yes.
Yeah.
Yes.
Thank you, Jeff.
No problem.
Have the students seen the videos? I'm curious if the students had any new understanding by watching the video of their piece get cut compared to the simulation that they did.
I don't know. Some were done live. There were a first few that were able to be cut right after the session yesterday, and those exist as YouTube or Zoom recordings. Those still need to get cut up. They're in one long take. And then like the one that we're watching right now and the others in the shared folder, those were recorded at a later time with my phone and tripod. So there's a little bit of a mix, but all of the files that were submitted were cut in some form. So
to the students, was there a different understanding if you got a chance to see your video? Was it like, oh, it looks just like my simulation, or there's probably a certain amount of excitement that came with watching it, right?
Absolutely, Carl. It was amazing. Like sometimes if like physically you put like, if I talk about like my case, in the simulation, we are simulating everything so perfect, right? And I was like going away with the tolerances of like little bit 5 mm and all those stuff. But when you are physically actually fabricating it, and if you are having like small error, then the tool is gonna hit the cube. And that actually happened. But then like we need to, then we see that how to improve that. So we add the tolerances a little bit more. And thanks to Jeff, Emily, Sarah, they stayed up like, late yesterday because of me. Thank you so much, guys. But actually we made it work. And once it's done, like after like working for 2 hours, it was like joy of 20 seconds that paid off all the hard work that we did.
But you
So,
got
yeah.
to see, yeah, like you were saying,
Yeah,
you got to see some
absolutely.
of the physical stuff play out
Yeah.
as well. Where we saw some challenges and very physical challenges, really. So.
Oh, this goes so smooth. Look at this.
Oh, this one was really lovely. The way that the file was designed to have one plane flow into the next, made for very fluid cuts, which was great.
Thank you, Jeff, for processing it. It also was sent pretty late.
That's all right. That's cool. I was excited by your first submission and wish we would have the opportunity to give that a try. But this was a really nice solution as well.
We need a digital Jeff too to be able to put in the file.
This is the digital Jeff.
Let's see at the end.
Well, I can still send you the first file if you could have a look just to show me how to.
I'd be curious. It would have to come back to you sometime next week at the earliest, but I'd be happy to take a look just because I'd be curious how that would play out.
Okay, so
this one was very challenging because of the orientation.
Via email or if I should upload it somewhere.
Email is fine, or you can upload it. So.
No, okay.
Your choice.
So, I don't know if I have your email, so I can either send it.
Send it to Sarah then.
Yeah, no problems, no problems.
Thank you, guys.
Yeah.
There was a student that was doing some research at U of M a couple of years ago. His name was Asa Peller, and he did hot wire cutting. He did like a really amazing project with hot wire cutting. But what's incredible about this tool, and maybe in comparison to like when you mill something, milling produces like sawdust. The hot wire cutter, he was doing things where, because the loss of material is just the thickness of the wire, he was able to take all of the pieces that were subtracted and put them together and have the piece that was cut out. And so he had all these negatives and positives of the work that he was doing. And because the only loss of material was just the thickness of the tool. And so really kind of, he was getting positives and negatives and drawing them and then remodeling things and looking at that process. It was really beautiful work, but there's almost, no waste with it.
Sorry, it's hypnotic to me. Okay.
Sarah, oh, you found it. Good. I was going to try and find this weird one.
Wow.
That was one cut. All those pieces just fell off from that one cut.
There are 4 total cuts, and they spiral, and so the wire cuts the previous cut piece. But it is kind of a fun reveal as all the pieces fall off. Our blocks aren't perfect, so there's some little pieces that I shave off at the end.
Oh, so that's the column. That's a Spartacus, right?
Yeah.
Yeah, we try to do this.
The artifacts that are left there are just from maybe the jiggle in the block as it was starting, or
creating a perfect 6-inch cube, we discovered in the build lab, is very tough. So none of the cubes are perfect. And one of the things that we could consider is to cut the side planes as a part of the code. And in some of them, that is the case. or turned out to be nearly the case. We just need to start with blocks of foam that are larger. So think about it: if you put a piece of wood on a flat CNC mill, you wouldn't mill all the way to the edges, and that's essentially what we're doing in this scenario.
Yeah,
it's working all the way to the edges. So,
so we learned something more, right?
Yeah, for sure. Here's one that goes all the way down and basically shaves the side as a part of it.
So this one is the same one.
Yeah, that's the same one. We
I have few videos of the same object. Great, sounds great.
It's interesting that all our renders sort of showcased white objects, and then we get to cut white foam as well. And that's actually the point we got to really start talking about, because for each of us, we were imagining like plaster or concrete. Someone else was imagining a whole different material. So I guess the ambiguity of these white renders sort of started a larger conversation of materials with the next assignment.
Yeah, so let's get this going. Okay, so how about we let you guys discuss a bit here. Let us know what's your process.
Hello guys. So this is mine, and this is Robo-mold. So my idea is like whatever we have learned in the past, like from CNC milling, hot wire cutting, I wanted to assemble all those pieces that we created to make a mold of like double curvy concrete element, which has like texture in it as well. Like as yesterday Carl described about that pinching method, I really like that. Like when you like wrap some clay or something, then pinch it, you're just displacing the material, saving it, making it sustainable, creating a nice form of shape. So inspiring from that, I try to like assemble all the elements that we had. That's how I have like named them. So the first one is CNC milling element 1. The second one is hot wire cutting art piece that we created yesterday for like arc cube. So what we are doing is we are taking all the arc cubes, we are assembling it, like picking and placing it to create a wall. If you go to the next slide. And then we create the bricks using element 1 and 3. And then in order to second layer, there will be like the element number 2. These entire thing will create a form, a mold work. And then at the bottom, you can be like pinch pack. You can pack the entire assembly and fill it with any solidifying material. And you can get the texture on the elements, like on the double curvy surface and the texture. And then it depends upon you if you want to like get rid of the center block, change the orientation, recreate something else, or you just want to keep it intact within that. If it is made of like a different material, it's up to you, like us. So that's just an idea of Robo-mold.
To me, something that I was trying to understand is what's happening here. Are you rotating the pieces? It's funny that it seems that you're recreating sort of the same assembly.
You're picking and all pieces are rotated in like different orientation. If you see, when it is placing, it's like rotating in different.
Now I see. Okay. Just because I was imagining like you laying down like the piece here in the middle. That's why I'm like, what's happening? But you're working with the rotations now.
Yeah. So it can be like and you can create different, like this is also having, the 4 sides, and 4 sides like matching with each other can create like, the accumulation can create like different designs. And then you take like double curvy surface and just pack it. So that double curvy surfaces will come out with the texture that is generated by these arc cubes.
And what's the scale that you're imagining for this?
Oh,
Like,
this
is
one is
it
like,
an
so this one is
installation?
like, the strip is 3 meters long. So this is like just a facade element that can be attached to, like, if you imagine, a line around it being a building, and then this part can be like, a ribbon or a cover or anything, a facade treatment that you're creating small holes. So this is like addition, but if you remove the central blocks, it will become like, hollow. So you can create it according to, like, simulate the wind and stuff, uh, the whole new facade kind of structure, parametric thing.
What's interesting to me is that, and I think that Karen Miser wanted to say something, but real quick, seems that it's really you wanted to put together all of the things learned this week. While I was imagining, like, this could be, not necessarily you need the pick and place, right? Like, to create this, because that's just scripting, right? Like, in the reality, like, if you had to, like, try to imagine, like, backward the process, like, you see this and you're trying to imagine, okay, how could we make this form, or like even like thinking about the material, in this case for like casting material. I was just imagining like that, like these forms could be simply like imagine the fabrication process. I don't know. Not necessarily. I see the robot being like crucial part just for the positioning of these elements, unless you made them like more crazy, right?
It is not separated. It packs. It like goes into each other and creates like a silicon mold kind of stuff. So it is packed, but like just to imagine the shape and stuff. I'm sure, yeah, that this is not the best way to explore this, but I just wanted to like know how it works.
Oh,
Quick question.
no.
Did you mean packed as in like it's almost like slip casting where
Yes. Yeah, it's
okay,
gonna close.
and how do you pour in the material? So this is concrete.
Yeah.
And what brings you to the 3-meter scale decision?
Oh,
because
it's just like
yeah, go ahead.
So the scale that you gave the other day, it was like 8 feet by 4 feet.
Mm-hmm.
So I used the same, and just because of like that extra stretch, I added a little bit to 3 meter, 3 point something. So it's like related to that table size.
I think it would be also interesting to sort of, you see how these touch points are coming and sort of resting on the surface. So if there were sort of multiple layers to it, so this has almost like a bone-like structure to it. So if, I don't know if this form was generated parametrically or
yes, I did.
okay.
Correct. Yeah.
I guess that could also lean on its structural qualities and why it starts to become thicker. Or so I guess in addition to the fabrication process, also like getting to the form is a process of its own, which can, I mean, and we understand that this project is literally just a day old, but if
no,
this,
and this form,
if it
like
was to have a spin-off.
I created in CNC milling, so I use the same form.
Yeah.
So if you see the CNC mill element 2, that was created, but in the different orientation. I use the same design.
And the intention is to have these foam, cut foam pieces as an in situ sort of, so they don't come out to create apertures, and they're supposed to be in place. Is that correct?
In place as in like?
I mean, so they're not, say they're not booleaning out your concrete. There are no sort of window.
So they're pinching it. They're pinching it.
Oh, they're pinching the concrete.
Yeah.
So, I didn't see that coming at all.
So that's why it says pinch pack. So it's like outside, but when the concrete is poured and then you like squeeze the mold, the concrete will be like pinched by this surface and the central cubes. It is just like a conceptual idea. I don't know, like, I don't think this is the best way to think. This is just a conceptual idea that how can we think about this robo mold stuff like double curvature and then add texture on it. It's not necessarily like this cube, it can be smaller, because always when you make like, a building that is double curvature, and if you want to make like small holes into it, it becomes very tricky in the doubly curvature. So how do you do that? Because even if we are placing like a circle in the double curvature, it will become ellipse. So that geometry is always like geometrical, but the form that will be created is not going to be geometrical in the end. And that becomes difficult that we can solve. But yeah, I don't know. Like,
Yeah, maybe you should definitely test it out over the summer, right? Just
yeah,
as a small, I mean, not 3 meters, of course, but even as a tabletop model, just to sort of test and test the process of it. Because I mean, concrete, it has a lot of like hydrostatic pressure as well, right? To sort of push back
yeah,
out, or like if that would give insights, I don't know, but I think it's definitely worth a lab test.
yeah. So yeah, that's the project, guys.
I think there's something, so I think it did take a while for us to understand it. I think it is pretty interesting. I think Misery's right. You'd have to have some type of soft thing that presses on the outside of that mold that would overcome the hydrostatic pressure of the concrete wanting to push out. What would those inserted elements be? Also concrete, precast concrete?
To be very frank, I don't know.
Because the other scenario is that, and not that I condone such activities, but if those were foam and inserted into the formwork, they could always be melted out later.
No, that's true. Yeah.
And so then they become a subtractive element from that other
Yeah.
piece. But the top left image, so I think there's a, again, one day's work, really amazing way to bring all of these different things together. But your top left image, I think is just gorgeous all by itself, in a way of kind of like putting those elements together. And I sent Sarah another project that's, I don't know, and I texted it to you, Sarah, which I know is one device to a different device. Or you're typing it in? I could, I have it open if you want me to share my screen.
Let's see.
So this is a young firm in Toronto. They both, husband and wife, they did their undergrad at LTU and then they did UCLA for grad school, and they've worked, and now they've started their own firm in Toronto. And it just reminds me like the image in your top left of just like putting together a series of elements, but there's a nice relationship between those elements that kind of builds a really nice kind of uniform quality. And it just reminded me of this project in the way that they were, probably made in a similar way. You could imagine almost this formwork being made with hot wire cutter and then precasting some panels, and just the way that there's mismatches between them and moments where some of those lines connect between them, I think is, at least for me, is one way of like taking some of those qualities that I see in your top left rendering and imagining them played out at a different scale.
Yeah, wow.
And I can share this in this chat as well. Second. Got it.
Because there's that, there's, I don't know, and I showed some of these things yesterday. We know what results when everything is the same. There's a different problem that emerges when things aren't the same, which is, do they go together or not? I think parametricism has given us a way to understand they can all be different and tied together. And what's nice is that there's that top left image for me finds a nice balance between those two, right? Some might be similar, they're kind of different, they don't all have to match up, but it does create a pretty amazing consistency in the language and a consistency in the form.
Yeah, awesome example. So thanks. More thoughts about this? I think it's, yeah,
Thank you
thanks
so
for
much,
your
guys.
efforts. That
Yeah,
that
and
was
thanks for
great.
going first.
Yeah.
Yeah, all the time, by the way. It's fun. Taco, if you want to share.
Well, the mine was a little bit easier, but well, this was a lamp prototype that we made here a couple of months ago to pass the bulb yarn around it. It has laser cutted wooden ribs. It's a parametric model that made all of the holes to pass the bulb yarn. So if you pass to the next one, my idea was to, inspired by that, to model this parametric sculpture that can be made as the same with the same idea. I'm focused more in the toolpath, not in the parts to be laser cutted, but to be in a 3-point curve, it's always will be the ribs always will be at planes. So so well, my idea, I was I was thinking that the robot can approach um, with a little angle uh, to the sculpture, but uh, with the simulation, I figured out that I was working like 2 hours and learning from the mistake to the robot to pass through the through the sculptor to so at the end uh, this crazy idea came to my mind to put like a stick as a tool to the robot could be upper, so the definition always is to like to put this like to put this line over the corner, and as you can see uh, on the right video, you can see how the extension of the line when it turns it passes through the point at the corner, so the thread it connects to the next point. So I think it might work. It's a it's a fierce approach of an idea. So well, the parametric model adapts to the toolpath. So that was my first intention to do it. But it kind of when I was working, ideas come through my head to do more with the robot because, as Carl mentioned earlier, uh, this has not an angle attack, so it's like a 3-axis movement only. But I think it might work differently. But it's well, that turned it out in one day. So that's it.
Did you find any references? It looks very similar, the approach, and actually the end effector, so that's funny, to one experimental project carried out in Milan with robots, and kind of like having this long end effector and using a wire to create these sort of sculptures, these objects. So to me, it was interesting, right? Like that's with like different materials, like different sort of intention in terms of aesthetics, but like a process that kind of like uses, like this articulated toolpath to uh, to create an object with lines, basically. So I thought it was interesting to see this deployed as your concept as well. There are videos if you check this out, and I can share this to you as well. You'll find also the animations and the videos to see how this works.
Yeah, I agree. It's a great effort. Also, with the first half of you scripting your geometries, I think you have this entire product line right there if you were to start making lamps. And then if you were to imagine this as like huge pieces, like something ICD does, there's quite a little sort of, you can almost imagine how I think what you're using there is that like jute? Like jute
Yes,
threading? All right,
yes,
yeah.
just
And the kind of filaments ICD uses quickly jumps to carbon fiber because it has to take care of the scale of it. And I think we looked at one or two examples from ICDs. I don't know what they're calling it, maybe the cocoon, or where they're using black carbon fiber to sort of really
yes.
wind it around.
Yes,
Uh,
I on the when I was looking for something similar, uh, all of the carbon fiber structure as pavilions and all things like that, I right there. So it's a lot more complex to
sure.
to
But
my
what's
idea,
interesting to
but
see, yeah, what's interesting is when they start with really small models, almost the
yes,
size that is similar to your lamp. In
yes,
a lot of ways, that's the testing ground because they're all just like tabletop models at first
uh-huh. Yes,
before
it's
jumping.
like a fierce idea because when when you have to assemble it manually, it's like you have to put some effort to the corners to add tension to the line. So I don't know how the robot will be always tensioning the the thread. So I that part is like the research of the of the fabrication progress, I think,
Mhm.
but it's like an idea.
Yeah. No, that's a great question for sure because a couple of days back I was watching how they make tension ropes, and what they typically try to do is they I mean the orientation at that point I guess becomes important because they're horizontal, so every time you're winding or maybe just your geometry is moving and the robot is static. I guess there are different ways to look at it in terms of uh, should your geometry be static and should your robot be winding around, or the other way around, and that would
Yes,
definitely
yes.
sort of give
One
slightly
one
different
yeah,
results.
a couple of things to mention will be like the when the robot is assembling, um, it might be a temporary structure to maintain the ribs on the place, like when they are connected, the uh, it will stay together, taking out the temporary frame, I think. On another thing is like it might be like a two-way, like one thread passes in one direction and in the other direction, for give the tension to work in both directions to give the structure. So I I don't know. So uh, like the first idea, I think is all right. So that one is interesting.
Here's an example
What's
that I
wrong,
just
Carl?
shared with Sarah. These are friends of mine, and they use carbon fiber. And so what you're doing is super interesting. And the learning that they had on these was that this is carbon fiber, that it actually, when it gets baked, the carbon fiber crossing one another is where you start to get the strength. And so what you could do within your Grasshopper script is start to shift your lists so that you're not just making rings with that, but you might go from like the first one to the third one to the second one and kind of jump between those. And as you start to layer that up, you start to see the crisscrossing that happens within theirs. What was interesting that they did, I want to say they laser cut cardboard as the formwork. And a really interesting thing, the temperature of baking the carbon fiber was less than would incinerate the cardboard. And so what they ended up doing was laser cutting the cardboard, using a robot to string the carbon fiber, baking them, and then submerging them in water. And the water basically dissolved the cardboard and the formwork dropped away. And so like a really interesting process about building up some of those things so that the formwork is not present anymore.
Yes. What a nice material research that was.
I mean, I think in terms of the process, yes. For me, the thing is that like, I think carbon fiber is disgusting as a material. Like you never want to touch it. And so maybe as a light fixture, what's nice and we talked about it a lot with their work, as the light fixture, you never maybe really touch it. And so it's okay because it's in space. And what's amazing about it is you get the kind of line of the filament and it's really strong and it's stable and it's rigid. But like, anyone proposing like carbon fiber furniture, unless it gets epoxied and finished and all of these types of things, it's a nasty, nasty material. But like you can imagine starting to play with the line.
Yes. Well, thank you, Go.
Carl, why is it a nasty material? Just to the touch?
It's like you wouldn't play with like fiberglass insulation, right? Like you end up getting like carbon fiber splinters.
Oh, even after baked and all that stuff?
It really has to be finished.
Okay. That's good.
Yeah. Yeah. And and you have to and then you're working with epoxy and then you have to wear a respirator and you have to wear gloves and you have to, it's dangerous too and dirty and
conditions extended beyond like manufacturing, not that it would be dusty all the time, but that there was a fibrous characteristic afterwards.
Yeah.
Anyway, I was just curious. Thanks.
Yeah. And maybe there are ways to deal with it in a better way, but it just compared to like working in a shop with wood where, and there can be dangerous aspects of working with wood as well, but just like something to the touch, that's not a material. And then in the way that I've seen anyone work with it, it's not something that I would want to go up and rub my hands over.
Oh, have you touched any of the structures from ICD?
No.
I wonder why they're obsessed with it.
There's a 3D printer as well that melts carbon fiber. Mm-hmm. If you want to work like neat.
Right.
But Espartco, I also love your idea of getting rid of the ribs altogether if the wires were intention. I think there's something really like worth pursuing there to sort of almost imagine if you have like a top and a bottom sort of like a holder of some sort, which lets you sort of almost thinking of it as yarn and how it gets interlocked, but the other one is actually pulling it down. So they're actually in position because of how they're sort of going over each other and pulling like piece one and piece two in the opposite direction and hence holding the geometry in place.
Miss Reed, that if you put some glue on this kind of material, it like when it dries, it like turn into a carbon fiber, but less with less strong. So
Mm-hmm.
now I thinking that the all of the ribs with laser cut and the holes can be if I manage to put some glue on the yarn and made all the structure, then I could some we could some take out the ribs and to have this structure only with the youth.
Mm-hmm.
And that view from above, when you show it, is like if you started to shift your lists of your points vertically, see how those are starting to crisscross and make intersections. Yes. I don't think they're actually happening in 3 dimensions yet, but if you started to shift your lists, you would start to get those kind of crisscrosses on the face of the object, which could be really nice.
Yes, totally agree.
Hi. Today I wanted to explore 3D printing columns, parametric columns. First, I have made it customizable. We can change the parameters, but as Spartacus projects. But when I did that, I realized it's not. It looks like very deterministic. I think maybe it needs a randomness. It's all.
And I think we have, like the Spartacus something hard every time that he likes a project. Yes, I guess likely enough, 3D printing has been around now for a while, and so it's nice to see how many explorations in terms of form have been carried out. We can see here some of the things we have talked about in terms of, having like simulate these experiments always in a perfect environment. So like flat, plain, and then perfectly like using a perfect material, sort of a process material to be 3D printed, which we call them as like a fancy concrete or fancy clay, and then like working on the parametric sort of aesthetics of this, and to me, it would be interesting like to start to imagine these things deployed with more constraints and try to understand if these objects interact with some pre-existing conditions in terms of like, it's time to me to start seeing these things more deployed at the larger scale. And if we think about larger scale, like the more we widen the angle, the more like the reality is less perfect and less flat and less everything. And we have environmental conditions as well. So I really, I'm really curious to imagine this. And I don't know, like in your idea, what these things are. Are they towers? Maybe I would, at least myself, I would hope so, really to imagine them scaled up in that sense.
Actually, I was inspired from Hans, not inspired, but I'm really interested in Hans Meyer's works, grotesque work, but it's not look like that for now. So it's like columns. Maybe I can pipes to the way of the, and I can make some variations from this project.
So to see them as an architecture.
Like, yeah, it's like a column.
Yeah, so just to me, it's interesting to push these things and to, you might be familiar with the work of emerging objects and really to see their experience starting from, like these objects and working with the patterns and textures and like three-dimensionally, and how these things evolved and got more crazy over time, really trying to push, as Carl was mentioning before, like really knowing the material and the limitations and what happens if you fire them, what's the temperature in which they start to change the status and so on. And so it's like getting things more crazy and then scale up more until we get to a point in which we start imagining this really deployed in architectural sense. So I think, yes, I'm just, I look forward like to seeing these things deployed more and and hopefully like for your design thinking, like you are starting really to push this and to see these things in terms of architecture, in terms of possibilities in construction. At least, yeah. Yeah, that's my point of view.
Also, one thing that's super interesting about emerging objects is that they're not just sort of taking 3D geometries and making 2D toolpaths, but instead designing the toolpaths themselves, which sort of results in something like what, yeah, that's actually a good example where you see like these drooping effects almost, but that's, I guess working with clay, a lot of it could be like this happy accident, but if you were to sort of predict and have greater control over that. Jeff, are you trying to? Yeah, go ahead.
Without recommending a specific outcome, I'd like to kind of say something like, or point back to what Carl said about shifting lists. I don't honestly know how all of this works, but in a parallel world, I do things with like modular electronics. And basically, you can maybe consider using another variable or another list to alter the target planes. So again, what we were talking about, sort of the 2.5 axis sort of paradigm, and these, kind of go up in a fairly traditional 3D print kind of way, but working with a robot, and as Mystery was just talking about, being able to design your own paths. If there were a list which altered the angle while keeping the target points consistent, so the layers are staying the same, but there's some kind of wobbling variable to the direction that the material is being extruded. I think that's where you start to see the type of surfaces in the emerging objects type category, because they're managing two sets of data kind of concurrently. There's a synchronization rate. There's the number of target points as they go around, and as long as the lists have the same length or a similar period, then you'll start to see things line up or drift with each rotation around. They slowly drift in terms of texture, in addition to other things. And I know that some other people are using like image maps to generate surface variation. I wish I had the link right now. There's a new book that came out that's all about like 3D printing with Grasshopper.
I think that Ramat and Kohler use that a lot, to use images so that you can detect like basically shadows and lights, and then you use them to generate a pattern. But Carl, do you have one of these, right? I'm jealous.
And the thing that I mentioned to them too, like thinking, I showed you guys the Gaudi hanging chain model yesterday and the way that we used gravity. And so one of the things I suggested to Virginia was like, if you show those examples, they print them upside down, and that's why the droops are all in the same direction. So I was like, it would be amazing if over the course of printing it, you started to change the orientation so that those loops might point up, out, down, sideways, left, right. And so you could imagine using gravity as you start to make that thing and starting to change it. Whereas you can see on those, the loop is always up because they're printed the other direction. I did have a question on the animation that you were showing. What's the difference? Like on the left, it looks really boxy or spiky, or are those just the planes, the representation of the planes?
Yes, these are
Okay.
planes.
Because I like
Looks
the messiness of those, and that maybe that's what Jeff is responding to as well. Like starting to see that kind of prickliness, or there's certain
like a
qualities.
Scrungy, exactly.
Yeah, and I think on the right, like having, maybe as old as I am and being around digital fabrication for as long as I have, that looks like a tool path on the right hand side, whereas on the left hand side, that kind of like, there are new types of qualities that are possible with that it's not smooth, but like a pretty incredible texture. And I think with the robot trying to mine some of those opportunities, looks like it has a lot of potential. Right, you could even imagine like discontinuous, having a bit, if you were milling, just like poking it at each of those plane points or something like that. It would give it a really kind of porous kind of quality. I remember, Sarah, I don't know, I could probably find a picture, but it'll take me a little bit longer. But in Matera in Italy, it's a really kind of soft stone. And I remember seeing these light fixtures that were just like drilled over and over, and it just makes it this kind of really porous thing. And so even just imagining being able to access all of those planes to do an operation would just be a question about like, what type of operation would we do? Could be additive, could be subtractive, could melt, could do any number of things.
it is true. This seems like a following iteration, like you start from this, or like maybe this is subtractive and then you add material, like multi-material kind of thing. Yeah, it is true.
And that's the other huge potential. Like robots are an infrastructure. It just allows us to connect three-dimensional digital space to physical space. We can put anything on the end of a robot that can then be calibrated, right? It could be additive, it could be subtractive. I've seen bandsaws, I've seen chainsaws, I've seen like water jet cutters. I've seen really scary things put on the end of a robot. But it's up to us to imagine what we put on there. And you could swap them out, right? You could do, like Sarah just said, you could do one process and then swap the head of the robot and then do another process with it. It could be additive, subtractive, a little more additive, a little more subtractive, and kind of work between the two.
Yeah, so I'd be curious to know, Mariam, is this additive or subtractive?
Hi, it's one is mine. This is a 3D printing simulation. And actually, I was searching the internet for some inspiration, and I came across a Soho building by Zaha Hadid. And I was kind of inspired by that. And I wanted to make a simple abstract tower. I say simple because I'm a beginner at Grasshopper and Rhino. And also, I thought that for making this simple abstract tower, using a metable component would be a good idea, because it makes things look organic, and because of its ability to meld things together in close proximity. So I created 3 points, and then I used metable component, and then I increased the planes so that I could have these curves that I could use them for this thing. And then the next part was the fact that I applied all the components related to KUKA PRC, just the way that was explained the previous sessions. Yeah, and yeah, I think that was it.
to me, it's interesting to see this, the toolpath becoming the leading aesthetic element, in this kind of thing. So you mentioned that building, and those layers that we are seeing are basically like the floor and then the glass part of the facade. So it's like floor windows, right? And we kind of, that comes very natural when we look at 3D printing because that's what it generates. And then as we have seen in the previous examples, we can create, deviations from that toolpath. But like the starting point is the layer. And so it's interesting to see how we're using that as how we are addressing those lines, those layers as a way to express an architectural concept. And I think not sure here how might really work the structure in this instance. It doesn't really matter at the moment because it's interesting just to see the concept as it is. Right. But
correct, yeah.
Yeah, just interesting. Like through this conversation, we have seen the line, like the stroke, deployed in so many ways. It's like either like we are connecting elements, like to create, and then we saw like a more complex, like the development of that idea with like a different articulation of target points, let's call them this way. And then, we're seeing like jumping through then architecture and 3D printing. So to me is that like the fact that it's kind of guiding our aesthetic values or like the understanding of certain things. And also like, I think, and there was in one of the lectures from Mario Carpo years ago, it was stating that like if you are trained as an architect, I think it's easy like to understand, for instance, what buildings are geometry based. So it's like the composition is based on geometric relationships, and what buildings are based on computing. And you can see that, you can see the calculus because of how like the appearance of the surfaces. And I think that's just scaling down a little bit this, so like not necessarily creating like crazy geometries, crazy panels like Dar or Gary have been doing, but just like going back to the sort of archetype, I don't know how to call it, like the layer of the 3D printing gives us an idea of how that thing was produced, or like just the fact that we have this mutual relationship between like our design and the tools that we're using for both design and creation and making. Yeah, so that's cool.
Thank you. Yeah, thank you.
And I think it would just be maybe one way that I would push the robot a little bit more is that right now all of your rings are horizontal. And so those could start, you could imagine those, and the Zaha building does produce a kind of nice form when we see those all as contours, but those could start to drift and start to intersect and start to do other things, because right now all of those float and hover. And so they like, what holds them apart? How do we start to think about some of those things? And so for me, the opportunity in solving what might be a problem could be found with the opportunities with the robot. But I think it's really nice to imagine how those objects might change and evolve and adapt. And we certainly have a technology to produce them now, which is nice.
Thank you for the feedback.
Yeah. Actually, I think Emerging Objects just recently did one of these structures where they do have a dwelling with like 2 rooms. Here, I can drop this link super quickly. But it's also nice to see that you're challenging the notion of scale with the robot, or would this mean it needs to have a machine of its own to be able to do this?
Carl, we have some kangaroo skills here deployed.
Hi everyone. That's
I'm here.
And in this practice, my concept come from the traditional architecture, like Adobe DOM. I wanted to simulate two DOM as a closed space, and the empty space between the two volumes can be open space. Then I use the Congo plugin to simulate the DOMs, and then simulated that with cuCopy-RC. I think these DOMs can be made with concrete or clay. I think it's in the market size, not very big in the like building, architectural building. And I modeled that. In next page, I put the perspective and at other view and the post-production of that. I think that's it.
We have a kangaroo expert here, Carl. Then I think you'll share some thoughts about about again like that process of seeing, you know, like the simulation of gravity and reversing the models and see what happens. Just wanted to mention layers.
Yeah, I mean, it's an interesting project. It has me thinking about things in a very different way because there's the issue of the scale, right? And I think the image I showed you yesterday of like the fingers placing the model into the bigger structure means that we need gigantic robots to do this. But if we could imagine leveraging the knowledge that we have, and so I have friends that are always talking about robo-dozers and being able to leverage, and there's a few people working on earth-formed structures. And there's also this incredible story that I remember hearing about when they were building the Duomo in Florence. They didn't know how to do it. And there was an idea to fill it with dirt, but mix pennies in with the dirt and then let people come and take the dirt and they could keep the pennies that were mixed in the dirt, right? And so this idea that you could use a robotic earthwork system to mound this in terms of sand or dirt or other types of things, and then maybe just pack it with concrete and then excavate that other material out, whether that be sand or something else. And so the kangaroo aspect then makes me think, well, being able to think about the physics and the materiality of things would be the angle of repose for whatever type of earth you might be using. So if you just keep stacking it up, right, it's going to start to find a natural shape. And so you could start to calculate what that natural shape is and then kind of use that as a temporary formwork or a temporary structure and then remove it. So I think there's some, and people are doing it both in an additive way as well as like excavating space out of the ground, filling that with concrete and then taking it out of the ground too. And so both of those things are possible. And so that's if we wanted to do this at a small scale, I think that's the robot would be the way to do it. If we want to do it at a very large scale, I think we could also leverage what we know, but with some different tools to actually do it.
Yeah, thank you.
Really interesting.
Thank you.
And this is the difficulty, right? This is the thing that's kind of as architects, all the projects that we point to as robotic projects are like as large as a pavilion, right? Because that's broken down at that scale, and that's the limitation, right? Is the size of the robot as we make things. And so we end up having to imagine it as a kind of aggregate system because we can only, the robot can only make something so big. Then we have to take those things and then we start stacking those up or start putting them together.
Yeah,
that's like a 30-story robot in the background, which I like that idea too.
Oh yes, me too. Yes, it's just interesting to see how these things are coming together, and now after only a week of workshop, we have a sense of like many of these things. So what's going on? What's the size of the robot? What we have to produce scale models? We understand. Like we look at this and we have a hint of like possibly what the material is. What are these dimensions? What's the production process? And it will be interesting, like in the future, just imagining that more robots will be deployed to build stuff. And so like looking at the toolpath, looking at the facade panels, the facade elements, and we know like, oh, that was this process through robotics. It's just another level of understanding of making, I think. Yeah, that's nerd. I look forward to seeing these things more. Yeah, so thanks again, Wahid, for this exploration. Yeah, it's nice. Yeah, thanks a lot for sharing. Jonathan,
Hi,
the floor is yours.
Yeah, I also looked at 3D printing, but particularly with concrete, because I was interested in kind of the inherent textures of both the material and the process of the printing, and then seeing how we could play with that. And so taking a linear sort of wall and manipulating the tool path parametrically to see what kind of new textures and kind of experiences that creates with the material and the fabrication process.
It's interesting that usually these kind of compositions are like pick and place exercises. And now you're like combining the processes to see, like the way, I think, I'm not sure if Matsu and Kohler were the very first ones talking about these things and trying to deploy robots to create a facade so that you could, make like bricklaying became something that could, you could add a static value upon that process. And yeah, so it's interesting that you're looking at, a way to imagine a process that historically we have been used to, to know as something that goes as like one piece at a time, is a discrete process using discrete elements. But you are looking at under a different lens, of course, digital fabrication, but also like imagine this as a whole in which you are like creating sort of like the single units, but like the production process is kind of like putting these things together. So at least is what I'm understanding here, right? That's the wall. That's not the brick that you're.
Yeah.
Right. So yeah, it's interesting to imagine these relationships in which, and when we have seen, and we mentioned this a couple of times, like when we have digital fabrication, so the building units not necessarily are tied anymore to our hands because we don't have to lay things anymore, or like it doesn't matter what's their weight, because maybe we have machines or we have tools to control them, to install these things outside. And so like imagine this deployed also in terms of like a sort of a brick wall, or like a wall composed of these discrete elements, not necessarily needs to work like that anymore. So we're kind of reversing like all the archetypes, or like all our ways of, imagining the construction of architectural units or subsystems and systems.
Also, just working with materials would also have like given amazing sort of feedback about if it's clay, how tall can you go, because it's also wet and soft when you're printing it, right? So that has its own sort of self weight to, or even once you start sort of contouring geometries, I guess, as against a normal PLA or a plastic 3D printer, you could keep going to certain extents. I think these material qualities would also be informing how many parts do you break it down in, or if we were to sort of start thinking about architectural elements or openings at some point, how does that interact with both the material and the process, but not as two mutually exclusive things that you think about, but instead it almost sort of feeds on each other for more information to sort of start prototyping it.
Yeah, I think that's something else I was interested in, the material property, which I don't know how to simulate in Grasshopper, but like with concrete, the deformation that it happens when it's laid down and how that also might affect the patterning and the texture.
Yeah, definitely, because it's a challenge in terms of, I mean, one thing is us trying to sort of simulate it on a digital platform, but also just like human errors when you're mixing clay before you put it in the extruder. If it has more water, it doesn't really matter how precise we got to the previous one, but this mix is completely new. So I think a lot of it, in my opinion, sort of even becomes intuitive after a point, almost like developing muscle memory of some sort.
Yes, one thing you can add to just as you had a robot printer is a little twist on the z-axis. I think like this kind of, I don't know, as you can see what I'm doing here on the right bottom. So that will compress a little bit some layers, but I think it would be a nice approach to add more complexity.
Yeah, absolutely. And especially complexity in the 3D, right? Like we keep talking about like the robot doing this and the world being like this, but then when you start really like creating complexity on the pattern, but also on the 3D space, just like to deploy more
like because
opportunities.
It seems like a regular wall to me, and as you have a robot, you can start to like that kinds of approaches to give more like a parametric look.
Yeah, because anyway, like the printing time, I mean, it doesn't really matter for the robot, like how complex the geometry is, as long as the tool can reach the target point, right? And that's one comment, like what you just said, the Spartaco is something that Carl mentions many times in terms of we have seen examples of, you know, robots drawing on a piece of paper, just like drawing a geometry, and we were discussing about like, okay, but what's the point, right? Like the robot could do way more difficult things. And if you remember, I shared with you guys a slide in which the students designed an end effector to draw, but like not on a flat plane, but to draw on a surface that was more articulated and more complex. So yeah, absolutely, I think that was a great point as Spartaco. You guys are sharing stuff in the chat log like crazy. Okay, you wanted to add some on this, and then we have the last project.
I think what's amazing too is just given what's happened over the course of this week, and what we see on the screen is the ability to start to simulate these things. And I think that's a huge help related to, like, as architects, us speculating in the studio and then imagining these types of things. It's one thing to model that wall. It's another thing to be able to, at your desk, before you even talk to a fabricator, be able to show how the robot might be printing that thing, right? And so you could imagine the difference. Well, and I'll tell one kind of joke of a story is that at least in the US, right, what we do is architects design something, we put together a whole set of drawings to go to bid, and then we send out those bids to contractors, and then typically the client selects the cheapest price. Terrible system, but a pretty common system. The joke is that you send out your drawings and you get a price back and it's too high, The architect tears out 5 sheets of the drawing set and sends it out to bid, right? Less drawings equals smaller price. And there was an architect in Boston who was telling us stories, like he did the set of drawings, printed them, really beautiful sheets, sent them out for bid, got a really big price. He tried a different approach, was he scaled them down and faxed them. I know you guys don't know what fax machines are, but he faxed them to a contractor and got a really low price because it was just like, he made his drawings look really disorganized. And so what I'm saying is that in those scenarios, the contractor was put off by like how sophisticated the project was. And this kind of mismatch between, oh, as a contractor, this is going to be a nightmare for me because of all of these types of things. I'm kind of now fast forwarding and saying like, oh, I know of a local fabricator. I looked on their website. They list what type of robot they have. Here I can simulate what their robot is doing and how it's making it before I ever even talk to them. And so being able to then engage that fabricator and be like, not only did I design this wall, and so like in your case, Jonathan, it's like, you may not show them the wall, you might just show them the animation of the robot making the wall. And they're like, oh, that's our robot. Oh, you know how to do this? Oh, you can give us those files? Ah, yeah, we'll happily work with you, right? As opposed to, you can imagine hiding the 2 robot animations and just sending them, oh, I want to make this wall, right? And they're like, wow, this is crazy. This is going to be super expensive. We don't want to do this. And so what I'm highlighting is just the incredible ability for all of you, not only to imagine the form, which is typically what we do as architects, but now to imagine the means of making that and to simulate it. It's not even, you're not just thinking like, oh, it'll be made by a robot. You're in control of that specific code. And so when Sarah talks about the master builder, this is empowering you as designers to be able to engage those things and engage those people and engage those fabricators and those tools. I think it's really, really interesting here as what this might mean for the practice of architecture. And you didn't have to 3D print it either, but I think it still points to the ability that we could.
No, it's funny that you mentioned that, because also with the kind of openings that architects are sort of considering these days happen to be, I mean, they're across various industries, and with these skills, like places like Quarrelstone, which is primarily a stone producer and fabricator, they are almost always looking for people who have basic understanding of the robots, but also understand the material, but are designers. So I guess it's also opening up a new position just as a way to practice and sort of take these things forward professionally. Or like places like Branch Technology is a great example of how they're leveraging these skills in a manufacturing setting.
Last but not least.
Hi, this one's for me. I get inspired from a project that I sent the link for you. It's a project from MIT that small robots weave a sculpture, and I was wondering how we could just create similar product with a KUKA PRC, which is a standing robot. And there were many challenges because the plan orientations was something difficult to handle, and the robot had conflict with the woven threads. And finally, I just reached this result. Yes, this is the project from MIT. The robots walk on the wall to weave, and they have really a great space to walk and don't have conflict with the threads. But in this example, there are many conflicts. I just handle to somehow reach a result, and finally I understand that why we don't rotate the model after weaving one side. And after 5 steps of rotation, we could finally reach some results. And this is a really terrible gift because I had to make it in the last minute. but I hope you can show see the orientation of the robot moving beside two frames and how it create the shape.
And it's funny to see, like, first of all, a Spartacus heart for your project, and then the fact that really all these skills we were discussing are coming together, and also like to see sometimes, you know, for instance, in the subtractive assignment, to see that some of you had this idea of topography in mind that you wanted to create, and in this case, like using linear elements sort of to create surfaces, or like to give a sense of a volumetric entity. It's funny how like we can see these concepts and deployed by you guys, even if you are like not working in the same room. But so I don't know, maybe you picked some inspiration from some of the discussions that emerged this week. And I think we have many elements here. Like if you look at this image that you dropped here, we can tell, right? Like that there is a sort of generative driven image. We can tell that, like, sort of we're visualizing the list of data, and then the fact that you pushed a bit the form, like since the examples that we have seen in the beginning, like the fact that you are making these things more complex through rotations and trying to imagine really what's the robot role in this scenario, I think it's very compelling. And yeah, again, using robotics, using one in the previous case, we were looking at the layers when we imagine an additive process. When we look at subtraction, we have in mind, you know, like what the toolpath that we will like trace on the material. And in this case, it's kind of like, it's not a pick and place, but it's like addressing some like material elements from one point to another and having this continuity that becomes like working with density, like creates something that we recognize as, I don't know, a loft or like whatever the relationship you have. It's interesting also because with, I think you mentioned this, Carl, yesterday, this summer we are working at CoEd with Gravity Sketch. We're working in the VR environment, and actually like some of the exercises that we are doing are, I don't know, they remind me of this notion of like creating a surface by like tracing lines, right? Like for them, like to build skills to understand what it means to have the controllers in their hands and to work in this VR environment. We ask them really like to trace their motion and to try to understand like the limitations of their body, of their arms, like imagining with like, you know, those points of singularity where like you can't go after a certain, you know, a rotation of the nodes, right? Like, and then at the end, you have a density of lines, and we push this concept a lot in terms of like create density, use the strokes so you learn how to use the software as well. But at the same time, at the end, we really visualize your body, the motions, and like your workspace. And with this approach, to me, it's just interesting to imagine this as something that could be deployed in digital fabrication as well. And yeah, the images are awesome, by the way.
Yeah, for sure. I would definitely commend you guys for sort of being able to simulate that as close as you can get to that action of you actually going to one frame, turning it around and going to the other. So I guess the logic with also when we walked you through pick and place, just the logic of breaking it down into, it's almost like thinking of it as pseudo code, right? If it was your hand, what would it be doing to say, okay, false, let's close the gripper, pick it up, translation and sort of open it back up. But projects like these have really interesting sort of clues from also the past, like weaving or crocheting or knitting for that matter. Or if you were to sort of see the evolution of like handloom machines and how they worked in like the 17th century and very quickly sort of got replaced by a CNC knitting machine. How and why that happened also gives us a lot of clues about what we could potentially do with a robot, which has uh, additional axes to sort of play around with. And I think that was one of the aims of this workshop, because as soon as Sarah and I we started sort of scratching our heads about what do we want to sort of expose them to, this is a great example of like its culmination, right? Because I think also this was all about like seeing enough projects or practicing enough building block assignments to sort of just use the final day to dream a little and start to speculate a little, and sort of ease out on how to make it as practical as possibly, I mean, as much as you can sort of make it a foolproof project, but instead to just it's not about shots in the dark, but more about how we can sort of forgive ourselves if we were to sort of make a mistake with certain processes that are completely defying gravity or completely defying the logics. But I think that intention of letting you guys dream a little with the speculative project, I'm very impressed.
Well, and it's a funny thing that Sarah mentioned the class that we're teaching this summer too. Well, I mentioned earlier how much I hate carbon fiber. And so the thought of laying in a nice hammock of carbon fiber just gives me chills. But here's a project where they're just using packing tape, and it has a really amazing material quality to it. And not that I would imagine curling up with a roll of packing tape either. But what I love about your project and what it makes me think about is for all of you to understand maybe some of the trade-offs of things. And so if like robots, a couple of problems that robots have in the way that we understand the robots is the strength of them or the rigidity of them. And so if you imagine even just your own arm, right, trying to mill a really hard material, is that all of the pressure is at the end, and all of that force has to go through all of those joints. And so robots are not super strong. Obviously they can get bigger, they can get more heavy duty, they can get really strong. But if you're going to mill a really heavy material, you tend to use a CNC router because of the rigidity of the equipment. That being said, robots as we understand them, and Bianco, they've been around for what, Sarah, 40 years? The notion of the robot arm that approximates a human arm. I think we're starting to see things with like Boston Dynamics and Spot, the example that you showed of the robot that moves on the wall. There's been some really amazing like spray painting briefcase robots that just are hung on a cable. And so I think like what I take from it is the ability to connect digital and physical, the ability for us to scan a space and get a point cloud now pretty easily, to then map that digital space, to then have a robot that can move in that space. I think your project and the precedent that you point to is one that says maybe the fixed robot arm is not the best way to go about doing something like that, but it's a robot that can move through the space, understand where it is, be able to map those kind of conditions and find a spot, anchor something, and then hang something, move to another place in the space. And so that's why I like, and the way that Misri talked about thinking about any process as a kind of script. And so the precedent that I sent to Sarah to put on the screen with the packing tape is a little bit like humans working like spiders with packing tape, right? They find a couple of key points, they string the packing tape between it, and then they just build it up and build it up and build it up. And it's in that repetition and aggregation of activity that I think the robots work really well, right? We get bored after doing something like 3 times, but we can make the robots do these things over and over. And the strength of the packing tape comes from just like multiple layers, you know, moving in this direction, moving in that direction, adding strength, adding more material, doing those types of things. And so I think your project is a really provocative one that I wouldn't get too, I mean, we're all super excited by robots, but I wouldn't get too fixed on the ideas of that this is what a robot looks like. I think they're going to change really quickly and bring new capabilities for us. And it's in this conflation of digital space and physical space, and being able to map those two things and have the digital twin is going to open up a lot of new possibilities for us in the next couple of years. So it's super exciting.
Thanks for the feedback.
Yeah, and I think that those were great comments to wrap up the session. We ran a bit long, but yeah, this was the last one, right? Yeah. And so, yeah, so I would like just to take a second, and I know that Misri has to run away as well, just to thank you all guys for this incredible week. It was just awesome for us to be in touch with you from all over the world, and hopefully you had a great experience. Hopefully this will impact your design, and you know, you will try to deploy more robotic fabrication and to understand this as just another add-on to your digital fabrication knowledge. And yeah, that's that's all on my end. Thanks for using.
I'll do my dean thing and thank all the students for joining, and thank Misri and Sarah and Jeff and Emily for making this happen. It's, as the dean of the college, it's really exciting to be able to engage students all over the world. And as I said yesterday, if you ever find yourself in Detroit, please come visit us. You're always welcome. But I think this is also an incredible networking opportunity. I'll speak for myself, but probably for Misri and Sarah and Jeff, is like, we'd love to see the work that comes out of this in the future and stay in touch. I mean, this is a great networking opportunity internationally and other types of things. And the work that was produced this week in a very short amount of time is really intriguing, really interesting, and I think points to a lot of potential for these things. So I'd love to track where you guys end up and how you use this and what we collectively do with these things. It's a small community of people, and stay in touch and keep pushing this stuff.
Yeah, just
right.
I want to
with
promote.
That, I'm going to run away.
All right.
Okay, bye, Carl, and we will promote.
And yes, I think at this point you should all be patting your backs for sure, because if I were there, I would totally do that. And commendable work. And because actually at first Sarah and I, we were just thinking about how much is too much, or and at one point we were like, okay, let's scratch the surface and see how it goes. But you guys have come through with flying colors, and how, like, I am really baffled by how much you guys have managed to sort of take away by the end of like 5th day, which is pretty amazing. So I hope we gave you a small window to sort of peep into this world of digital fabrication, which is ever increasing at this point. But definitely stay in touch, and we'll definitely be in touch with you guys to sort of see how we can document it really well. Maybe each of the projects could have a small little introduction or what the project is about, just so we can compile it all together and say, hey, this is what we did for 5 days, just about 2 hours every day, which is like 10 hours. If you think about it, it's not that long. And I really appreciate the hours you put into these projects, even outside of workshop hours, right? In addition to whatever you guys are up to right now. So kudos to you guys and the team at Bill Lab for making this happen so seamlessly. Both Jeff and Emily sort of just be so approachable. That was fantastic. Thank you so much.
Yeah, thanks a lot again. Thumbs up, and we'll keep promoting. Actually, we'll start promoting your work on social media these days.
Absolutely.
So, thanks a lot again.
Thank you,
And
guys.
All right.
All
Thank you.
the
Thank you so much,
around.
guys.
Ciao.
It's been an amazing week.
Yeah.
Good work produced because you've been like good teachers and pretty clear about like, passing the knowledge to us. So thank you so much for that. And yeah,
all
I'm
the
very
team.
happy that you
all
had
the
a great experience. Thank you, guys.
absolutely.
Thanks.
Absolutely.